Hi everybody. This lecture is dedicated for something called Euler Formula. And Euler Formula, is going to help us to understand the relationship between exponential function and trigonometric function. It said that e to the power of j theta is equal to cosine theta plus j sine theta. So that's the Euler's formula. If you have e to the power of minus j theta, so it's easy to deduce the relationship is equal to cosine theta minus j sine theta. That's equation 1, equation 2, and if you add both equations, will be e plus j theta plus e to the power of minus j theta. When you add them, you have cosine, and cosine will add to 2 cosine theta, but when you add j and minus j, they will cancel. So divide both by 2, so you get cosine theta is equal to e to the power of j theta plus e to the minus j theta divided by 2. So that's, the first relationship we can get of cosine theta. If we do subtract the both equation 1 and 2, so we'll say a j theta minus e to the power of minus j theta. It will have cosine theta minus cosine theta, that will be 0. J sine theta minus minus j, it will be 2j sine theta. Accordingly, we can find sine theta is equal to e to the power of j theta minus e to the power of minus j theta divided by 2j. So that's how can you get the sine function out of the exponential expression. I have some kind of other relations that it will help you to understand how to simplify complex exponential form of Fourier series to trigonometry, or you can at least, if you faced in any mathematical problem, how can you convert the sum of exponential expression into trigonometric expression. So let's start. Now let's just say that cosine, if you have cosine n theta. So what's cosine n theta? Cosine n theta, according to this equation, let's call this number 3, and this is number 4. According to number 3, cosine n theta, you just replace every theta by n theta. So it will be equal to a 1 or 1/2 e to the power j n theta plus e to the power minus j n theta. All right. Well, what about if I want to add like 3 terms of cosine n theta from n1 to n3, like on cosine theta plus cosine 2 theta plus cosine 3 theta and so on. So I will say if I want to find the sum of cosine n theta from n equal 1 to n equal 3, I will just add the equivalent expression to here expressed on the right hand side. The same thing. So I'll say is equal half the sum of this expression j n theta plus e minus j n theta from n equal 1 to n equal 3. Let's just divide it. So I have half, and I have the sum n1 to 3 a j n theta plus the sum from n equal 1 to 3 e to the power minus j n theta. Okay, I will just write it again. For the first term, I will leave it. And I'm interested now, what should I do if I write here e j n theta? So do you think that will be appropriate to use, from n equal 1 to 3 in this expression? Do you think it's still valid? I mean, I will keep the limit, or I should add a negative sign? Yes, of course. So, I mean, to keep the second term here, like this one, I just write from n equal to -1 to equal to -3. I will get the same. I will get the same result. I will get the same result, right? Well, now I'm having both terms the same, AG in theta, AG in theta, but there is one from n to 3 and one from -1 to -3. So actually I am summing the term E, G in theta like 6 times. One time start from -3, -2, -1, 1, 2, 3. Now I can just write it like that. From n equal to -3 to n equal 3, and I have to make it clear that I'm not using n equal 0, right? We didn't pass by 0, all right. And I have the half here. And here the same thing that we did, from n equal 1 to n equal 3, cosine n theta. Well, this expression really will be important when we are dealing with exponential or complex exponential form of Fourier series. Sometimes you need that, and other also mathematical problem. But let's just, I mean, make it now general. If you are saying now the sum of n started from -infinity, now we're going to make it general, to plus infinity, where n not equal 0, cosine n theta. Now it could be written as we did here, 1/2 the sum from n minus infinity to plus infinity, e to the power j n theta. Now this one has to be fixed. It's not the same. Actually, we'll start this from n equal 1 to 3, so I have to start from n equal 1. This is the only one that should be minus infinity, infinity, right? Because, I mean, the original problem to find from 1 to 3. So that will be a good, useful expression to express the sum of cosine term. The same thing, but I'm going to write it down now without proof. You can just prove it. It's very similar. You can say that the sum of n equal 1 to infinity for sine n theta will be equal 1. The first difference, I have 2j, that's an expression, but the same thing will be here from n equal minus infinity to plus infinity aj n theta. That's another useful expression that you're going to use. I also want to stress about some kind of trigonometric relationship that will be helpful in the Fourier series. When you will find sometimes, I mean, you want to simplify something like cosine n pi. Cosine n pi. Well, let me refresh your memory about the unit circle. Cosine n pi, this is, I mean, 0, that's pi over 2, that's pi, that's 3 pi over 2. So cosine n pi, n sometimes could be 0, 1, 2, 3, 4, 5, and so on. Obviously, when you go on this side, n will be equal 1. So we'll have cosine pi. The value of cosine pi is equal -1. So actually it's equal -1 when n is odd. When n is odd. But when it is even like 2 pi, it'll come 0. It will come here. I mean, and then cosine 2 pi is equal to 1. So it's positive 1 when n is even. So that's for odd n, and that's for even n. That's, I mean, all right. Let's see what's happening now if you have sine. What's the value of sine n pi? In pi, it means here and there, and the value of the sine is equal 0. So it's equal 0 for all n's, even or odd. All right. Now we'll have another thing. If you have cosine n pi over 2, what you're going to have? Let's look here. Have pi over 2 when n equal 1. Let's look at the odd. That's n equal 1, that's n equal 3, because this is pi over 2 multiplied by 1. Pi over 2 divided by 3. So on this vertical axis, the cosine is equal 0. So you can say it's equal 0 when it's odd. N, like 1, 3, 5, 7. What about even? Even is different. If you multiply, or you replace n by 2, so you have 2 pi over 2 pi cosine pi minus 1. So say, okay, that's minus 1, that's 1 even. Take the second even, 4. When you put 4 over 2 is equal to 2 pi, it will be equal plus 1. So it will be equal plus or minus 1 when it's even. It's alternating, eh? Negative 1 plus 1, negative 1 plus 1. So that's for even n. It's going to be alternating. Now let's look for the sine n pi over 2. Sine n pi over 2. Well, check if you have even first. If you have 2 over 2 will be sine pi, that equals 0. Choose 4. 4 over 2 is equal to 2 pi, 0. So it's 0 for even n. And when you do the odd, then you will get plus or minus 1. So that's all, and I think that'll be helpful that when you solve any problems, keep this sheet with you to simplify your expression. And thank you for your attention.